Hi, and welcome to part 2 in our video series where we teach you how to get started developing Swim applications. If you are unfamiliar with Swim, be sure to check out our Intro to the Swim Architecture video. That will give you a great overview of Swim, web agents, how they are different, and how they can change the way you deal with data. Also be sure you've watched part 1 of this video series, where we show you how to download and run our Swim Plant Monitor application, and we also review our development environment, dev tools, and everything you need to get going. Links to all this in the description, plus we'll have links to our developer site and our documentation. Now let's get familiar with the high-level structure of the application. In this diagram, we are feeding in data from a data simulator that's running inside of a second web page. We will review how that simulator works, as well as other ways to get data into Swim later on in this. The data simulator uses a Swim client to send commands to our Swim application in order to update the web agent with new data. Generally speaking, the Swim client is used for connecting to our web agents by creating downlinks for receiving data or for sending data via command lines. Here we're using the JavaScript client, but we also have Java and Python clients as well. Web agents in Swim are created automatically the first time they get called. They have a few methods such as will start and did start, which will get called on startup that you can use to initialize things in your web agent. For example, you can pre-populate a lane with static data from a CSV file on startup, which the web agent can then reference back to later. When our application starts, it creates a single aggregation agent, which everything else will end up talking to. In this example, there can be many plants or sensor web agents, but there will always be only one aggregation agent. When we start up the data simulator, we first call the create plant command on a plant agent using a unique ID for that plant, and then pass in additional data about that plant to the agent. This fires up a new web agent for that plant based on the ID that we gave it, and it stores that additional data inside lanes inside the web agent. Next, the simulator starts sending simulated data over the command lanes to the sensor agents. Each sensor gets a unique ID, and also has additional information used to link back to its parent plants. Inside the application, each web agent gets created and reports to its parent agent that it has been created and passes info about itself up to that parent. So in this example, when a plant agent gets created, it tells the aggregation agent about it. Likewise, when sensor agents are created, it tells the parent plant agent about that creation. With this structure, we've basically created a virtual greenhouse of plants and sensors. The greenhouse has a stateful web agent and the aggregation agent giving you a list of all the plants in the greenhouse and the current state. Every plant also has a stateful web agent with a list of all the current sensors, and likewise every sensor has a stateful web agent which holds the current sensor value along with a history of that value which will be graphed later in the UI. All these agents are able to communicate with each other and are able to act upon that data in real time. Now, let's take a look at how all that works. The code for the Java side of things lives here in Java src main. There are two folders here, Java and Resources. The Java is our Java code base, and Resources contains a file called Server.recon, which is used to configure our application. Next, let's look at a bit of code. Here we have our application plane class. It extends the Swim abstract plane. A Swim plane is the top level of a Swim application, and it defines the space in which all of our Swim agents will run. Moving on to our main method, first we define a Swim kernel. This will be used by our Swim space to run everything. Then we define our Swim space by calling getSpace on the kernel using the name of the space that we pass in. Here we say Plant Monitor. So what does all that mean? If we take a look at our Server.recon file in the Resources folder, you'll see the first thing there is also Plant Monitor. What this is doing is defining the fabric of the Swim space and all the web agents and planes which will make up that fabric. Plant Monitor is the name of the fabric and is what will get loaded by the getSpace call in the application plane. Let's take a minute to go over what all is in our Server.recon file because it's important and there's a lot going on. This is part of how we turn our code into an application structure and link code to concepts. First, inside the fabric definition, we define our plane and link it to the proper class file. Next, we define several nodes. Each of these nodes is an agent definition and defines each type of web agent which will make up our application. Each node has a pattern whose value defines the URL that will be used to access that web agent. These URLs can have wildcard parameters, allowing for a given node to have multiple web agents. The agent field lets us link the actual Java class to the agent being used. Be sure any Java class used here extends abstract agent. Finally, down here at the bottom, we use @web to define our web server. The space value here tells the application to serve out all the web agents for that space over the port defined. Here we're using port 9001. The document root value tells Swim where it can go find the files for the UI. Document root is optional, so if you leave it out, Swim will only serve out the web agents. Now that we've gone over how the application is structured and configured and how to define web agents, let's finally take a look at some actual web agents. Let's start with the aggregation service agent. In this agent, we define a number of swim lanes. What's a swim lane, you ask? Well, a swim lane is basically a place to put various forms of data, and it's a key part of Swim web agents. There are a number of lane types, but for this demo, we're going to stick with the most commonly used ones. That being value lanes, which hold a single value, map lanes, which is like a hash map, and command lanes, which we use to send data into or trigger actions within a web agent. The first lane we have is called plant list. This is a map lane which will hold a list of all the plants. Each plant ID is a string, and so in this map, we use the string as the key. And we use a swim value to hold all the information about that plant. Next, we have plant alert map lane. Sensors on a plant can generate alerts, and this will hold a list of all the plants which have an active alert. Again, we use a string for a key and a swim value to hold the number of alerts that plant has. Now we come to our first command lane. The add plant command is what gets called by plant agents when they are created to notify the aggregation agent that this new plant exists. We grab the plant ID out of the swim value passed into the command, and we use that to put the new plant on the plant list lane. The add alert lane is called by a plant when one or more of its sensors generates an alert. This command simply grabs the plant ID and alert count for the value passed in and puts that value onto the plant alert lane. Finally, the remove alert lane does just what it sounds like it would and removes alerts from the plant alert list. So now let's take a look at the plant state agent. First, this show debug value is here, so you can turn on some helpful debug output, which shows what's going on while the application is running. It's helpful for getting an idea of when and how things get called once the application is running. Our first lane here is a simple value lane. It holds static information about the plant, like name, ID, and other information, and it gets populated when a plant is created. Next, we have a sensor list map lane, again using strings for keys and a value to hold the sensor information. Alert list is much the same as sensor list. The key is the sensor ID and the value is information about that sensor. Now we come to our first command for this agent. This create plant command is called by the data simulator on startup. The command lane simply takes the value passed into it and puts it into the info value lane above, and then calls the add plant command on the aggregation agent with that same value. The add sensor command is much like the create plant command in that it takes a value passed into it and populates a map lane with it. However, it does not report to the aggregation agent. Finally, we have the add and remove alert commands. These get called by sensor agents when a sensor triggers an alert. Both of these commands also report to the aggregation agent to update the alert counts there. Moving on to the sensor state agent, this class starts with a few variables which we will use later on. Next, we have a value lane which holds the name of the sensor. That also gets populated later on. Next, the latest lane is also a simple value lane with a float data type. This will hold the current sensor value. This lane is a bit different in that we have some extra stuff going on. This did set is something which exists on all value lanes and will be called anytime the value in that lane changes. You can use this in a variety of ways, such as triggering other actions or populating other lanes. Here we create a timestamp and use that as a key to add an entry into another map lane called history. Now this gives us a place to get the current value of the sensor along with a history of sensor values keyed by timestamp. Both of these lanes will be used later in the UI to visualize the sensor data. You will notice this check alert call. We have mentioned a number of times now that the sensors can trigger alerts, so let's go ahead and talk about how that works. New data comes in via the set latest command and is called by the data sim with new sensor values. This populates the latest value lane and triggers that did set call we just talked about. You'll see that we also have a value lane called threshold and a command lane called set threshold. All these values are used by the check alert method to basically test if the current value in the latest lane is less than the current value in the threshold lane. The threshold can be changed by the user in the UI, so that each sensor can potentially have a different threshold value. The checkAlert method uses swim commands to update its parent plant of the alert state for that sensor. This is a great example of a way you can process and act upon data in real time as it comes in, and how to update other parts of the application with that state. All this happens in memory at the data source with a tiny amount of overhead. That tiny overhead means you can run your whole application on something as simple as a Raspberry Pi, and barely make a dent in the overall overhead of the device. A few final things to point out. First is the setInfo command. This is called by the data sim to create the sensor for that plant, and then reports its parent plants that has been created. This way, any plant can have any number of sensors without any sort of change to the code or the configuration. Finally, we have this didStart call, which we can override on the base abstract agent class. In this call, we pre-populate some lanes with default data. This is purely to make the UI happy later on. So there you go. That's all the code which makes up the application side of this demo. If I missed anything, or if you have any questions, please feel free to reach out and ask. We'll have lots of links in the description for ways to reach out, as well as developer resources, and you're also free to just ask in the comments below. Our next video will cover how to use the Swim UI toolkit to create a real-time interactive UI using all of these web agents. Thanks for watching, and see you next time.